Hi, we have the AP Physics 1 past paper 2016. We are discussing the section free response question. We have the question number 2 for the point 12. In this question, he asked a new kind of toy ball is advertised to be bounced perfectly elastic of the hard surface. Students suspect, however, there is no collision is perfectly elastic. The student hypothesis that collisions are very close to being perfectly elastic for low speed collision, but deviate more and more for being perfectly elastic as the collision speed increases. That's the hypothesis of the student. Okay, in question A, he asked to design an experiment. The student hypothesis about the collision of the ball with a hard surface. Student has equipment that usually find in a school laboratory. What quantities would be measured? First, we have to discuss this. We have to see two heights, vertical distance from the ball center to release to the contact surface, drop height that is called, rebound height, maximum vertical height the ball center reaches after first bounce. These two heights we have to calculate. Explanation: the elasticity of the collision is measured from the coefficient of restriction, which is the ratio of speed after the bounce to the speed before the bounce. So we have to know the speed is k root 2gh to h prime for the after bounce, h is before bounce. So we have to calculate two parameter, drop height and rebound height. For perfectly elastic, E is equal to 1. There means there is no loss of energy. That we have to discuss for the low speed, and inelastic for E is less than 1. Some energy is lost at the heat and the sound. So that is the case for the high speed according to the hypothesis of the student. Okay. What equipment should be used to measure and how the equipment should be used? We have to come with meter stick, hard surface, and the smartphone with the slow motion camera and the toy ball. That's the question about. First, meter stick is used to measure both heights h and h prime. It clamps vertically next to the bounce area with zero mark at the hard surface level. Height can be read directly from the scale. Smartphone camera help to record the fall and the bounce of the ball in slow motion for accurate measure of h and h prime. In next part, he asked, describe the procedure to use, test the hypothesis, give enough details so that another student could replicate the experiment. Okay, we have the procedure, detailed procedure. Clamp the meter stick vertically with the retort stand with 0 centimeter mark with the hard surface. Ensuring setup is stable. Hold the ball at the height h using the clamp or carefully by the hand, release without pushing. That's the main thing. No forces involved. Let it drop straight down into the hard surface. Observe and record maximum rebound height, mean h prime, using the video. Record the drop, play back in slow motion, pause at the peak to measure so that we get accurate rebound height. Drop, repeat drop 3 times for the measurement error. Sometimes there is a slight angle in drop, sometimes air resistance. So to counter this, we have to do this experiment 3 times. Next, we have to repeat the same experiment with next initial height. So initially we have to change initial height at least 5 different heights for reasonable speed range. Calculative derivate for each observer we have h and h prime, so we have to compute E. Comparing the value of E is equal to 1 for small h E, but E decreases for the large h. Hypothesis is supported, vice versa would be there. Okay, the second part, describe how would you represent data in graph or table. Explain how that representation would use to determine the whether data is consistent with the student hypothesis. Okay, if you seen the golden line, that is the directly proportional, but as the you see drop height is increased, the ratio doesn't follow the E is equal to 1. The drop height is coming low. That's the only projected area, but the drop height is not directly as proportional to the rebound height. So student hypothesis is correct for small h is equal to 1, low speed E decreases, h and increases. So graph slope downward, h increases, data consistent with the hypothesis. Student carried out the experiment analysis describe part A and B. Student immediately concludes something went wrong in the experiment because the graph and table behavior is the elastic for low speed but appear violate the basic principle of high speed collision. Give an example of the graph that indicate nearly elastic behavior for low speed but appear to violate basic principle for the principle of high speed. That would be the speed. Students see the low speed ball behave in this area. You can see there is a linear behavior between drop height and bound height. But in next part, you see there is a change. Now you see rebound height is more than the drop height. That's mean at high speed balls seem to bounce higher than the release point. So that's the in initial h is equal to h prime, but curve goes up above the state for a higher value. It is moving up, red line, it's moving upward. Now, what principle is violated in the graph? In part C, several physical principles might appear to be violated, but nearly identify one. So, basic is law of conservation of energy that appear to be violated. In isolated collision, no external energy is added. Kinetic energy after the bounce can't exceed the kinetic energy before. So, H prime cannot exceed the H. mgh prime greater than mgh, which would mean more potential energy after, that is E is greater than 1. Energy would be created, which is impossible. That's the situation which is violated. Okay, that's the answer. If you have any query, kindly ask in a comment. Okay, take care.